Hi everyone. Today we learn all about breadboards and we'll also build a circuit on one. So here I've got two sizes of breadboards. The smaller one has 30 rows while the longer one has 65 rows. So you can use either one for today's circuit. So now let's turn our breadboards this way. It's a good idea to place your breadboard this way on your table. This makes it easier to map the points. Let me bring a book to it next to it for reference. So keep it this way. Keep it this way on the table such that the number 1 is on the top left. So now these numbers 1, 2, 3, 4, these are the row numbers. And A, B, C, D, E till J, these are the column numbers. So on a longer breadboard like this one, the row numbers are printed this way, 1, 5, 10. So these are in intervals of 5. So row number 7 would be 2 rows after 5. And row number 23 would be 3 rows after 20. So 20, 21, 22, 23. So that would be row number 23. Now let's see what's inside a breadboard. So sockets are connected like this inside a breadboard. I've drawn these colored lines to show the wiring underneath. Imagine each of these lines as a metal wire. So we have a metal wire connecting points 1A, 1B, 1C, 1D, and 1E. Now, E and F are not connected. Then there is another wire connecting 1F, 1G, till 1J. So these 5 points are connected together. Now let's look at row number 20. Here again points A to E are connected together. And then points 20F to 20J. These 5 points are connected together. On the left, there is one long wire running across all these points. So these points are connected together through one long wire. This is called a bus rail. There is another bus rail right next to it. And on the right, this bus rail has all these points connected again with one wire underneath. Now there's nothing positive or negative on this breadboard. Manufacturers just mark plus and minus as a guide to help us in connecting components. Let's start connecting components on it, and it'll all make sense when we start building circuits. Let's build a simple circuit to light up an LED today. These are the components we are going to need. A breadboard, two 1.5 volt cells, a push button, a resistor, 120 ohms resistor is what I have used, but any resistor from 100 to 220 ohms would do. An LED of any color, and two jumper wires. So the jumper wires here that we are going to use are the ones with pins on both the ends. So these jumper wires should have pins on both the ends. And two alligator clips. Now let's build the circuit. So this is the circuit diagram for the circuit we'll build. So we have 3 volts battery. So plus of 3 volts battery is connected to the resistor, and the other end of the resistor is connected to the plus of the LED. and the minus of the LED is connected to the minus of the battery. So we'll need two 1.5 volts alkaline cells to make this 3 volts battery. So let's start with the LED. You may choose LED of any color. Now this LED can be connected across any two rows like this. So here, one leg could be inserted on row number 6, the other could go on row number 7 or 14 and 15. So it could be connected across any two rows, but it should not be connected across this way. This way, here. It should not be connected across this way. So here on the same row. So here we have one leg of the LED on 4F and the other on 4G. So it's on the same row on F and G. Current will flow through the underlying wire on the breadboard, which is an excellent conductor, and LED will not light up. This can lead to a short circuit. So it should not be connected on the same points, on the points which are connected with a wire like 4F and 4G or 8C and 8D. Again, C8C and 8D are connected with a wire underneath. So this can cause a short circuit again. Or 15B and 15C. So now let's insert the short leg of the LED on 7C of the breadboard here, row number 7, column number C. The short leg goes on row number 7 and column number C. And the long leg goes on row number 8 and column number C. Let's add the resistor now. So the plus of our LED is connected to one end of the resistor. Now to make this connection, a resistor can be inserted on any of the points from 8A to 8E. There is a wire running underneath 8A to 8E, a wire which connects these 5 points together. So all we need to do is insert one end of the resistor on any of these 4 points and it'll be connected to the plus of the LED. So here I have inserted one end of the resistor to 8B, so row 8, column B. And the plus of the LED is on 8, row 8, column C. So here 8B and 8C are already connected with the wire underneath. I don't need to use an external wire or an alligator clip to connect this resistor to the LED. Just by inserting it at 8B, the connection is formed. They are connected. So one end of the resistor is on 8B and the other end of the resistor is on 15B. So let's move on to the next connection in our circuit. There, the other end of the resistor is connected to the plus of the battery in our circuit diagram. So to make this connection, we can insert a jumper wire on any of these points from 15A to 15E. and that jumper wire will be connected to the other end of the resistor. So here I have inserted a jumper wire on 15D. So 15D and 15B, where the resistor is. Our resistor is on 15B and jumper wire is on 15D. Now these 2 points are already connected with a wire underneath in our breadboard. So we don't need to use any external wire to connect these 2 points. So this is how we'll make this connection. So we'll need a jumper wire and an alligator clip to make this connection. Let's use the red jumper wire and red alligator clip to connect to the plus of the battery. So here, let's get our red alligator wire with pins on both the ends. Now connect it to the plus of the battery through an alligator clip. So you insert the jumper wire on 15D and the other end of the jumper wire is connected to the alligator clip, and the other end of the alligator clip is connected to the plus of the battery. Now let's make the very last connection in our circuit. That's from the minus of our LED to the minus of the battery. So the minus of our LED is the short leg, which is on 7C. So the short leg of the LED is on 7C. So we'll take a black jumper wire from our cell, from our 3 volts battery, and insert it on, we can insert it on any points from 7A to 7E, and it'll be connected to the short leg. So here I have inserted the jumper wire to 7A. So now 7A and 7C have a wire running underneath in the breadboard. So they don't need to be connected again through any alligator clip. So all we need to do is get a black jumper wire and insert it on 7A, and it'll be connected to the LED, the short leg of the LED. Let's get a black jumper wire with pins on both the ends. Insert one pin on 7A, row number 7, column A, and the other end of the jumper wire is connected to a black alligator clip. Let's connect it to a black alligator clip, and the other end of the clip goes to the minus of the battery. So there, our circuit is complete and LED lights up. So let's review our circuit on the breadboard. You may review along. So let's start with the very first, the top row. So here we have black wire, a black jumper wire connected to the minus of the battery. And this black jumper wire is on 7A. On 7C is the short leg of our LED. And the long leg, that's positive of the LED, is on 8C. Now one end of our resistor is on 8B. And the other end of the resistor is on 15B. And on 15D is a red jumper wire, which is connected to the plus of our battery. So that's our circuit. Now let's add a push button to our circuit. So this is a push button. It closes a circuit only when it's pushed down or pressed down and opens the circuit when it's released. It's got 4 pins underneath. So now let's add it to our circuit diagram first. So this is the symbol for the push button. It has a metal plate which gets pushed down every time we press it. So now let's add it in series with other components in our circuit here. So it's going to light up our LED only when it's pushed down. So here, let's add it here. So one pin of the push button is connected to the resistor and the other pin of the push button is connected to the plus of the battery. So now this LED is going to light up only when the push button is pressed, and it'll turn off when it's released. So only when the metal plate touches these 2 points, the circuit will be closed and LED will light up. So let's build it on our breadboard. So let's add the push button between the resistor and the positive of the battery. So first we need to remove the jumper wire from 15D on the breadboard. So let's remove the red jumper wire from here. There, we remove the jumper wire. Now, let's insert the push button such that one pin is on 15, row number 15, column E, and the other pin is on, the bottom pin is on 17 and column E. And the other 2 pins should be across on 15F and 17F. So let's insert it such that there's just a gap of 1 row in between. So you have 15E. Make sure one pin is on 15E and the bottom pin is on 17E. Now, let's connect the other end of the push button to the plus of the battery. So now insert the jumper wire on 17, on row number 17. So our jumper wire can be inserted on any of these points, 17A to 17D of the breadboard. So here I've inserted it on 17B. So we have our push button on 17E and the red jumper wire is inserted on 17B in there. And it's connected to the plus of the battery. And this completes our circuit. So now the circuit is closed every time we push the button. So only when we push the button, the LED goes on. And it turns off when we release the button. So there you go. That's your LED circuit with a push button. That's your first circuit on breadboard. And there is a home activity for you to do this week on the next slide. So the home activity is to add another push button in series in your circuit. So can you add another push button in series in this circuit? You need to draw the circuit diagram with 2 push buttons. Add it on your breadboard and see what happens when you press just one button and what happens when you press both the buttons together. When does the LED go on and off? So that's your home activity for this week. So that's it for today. Have fun with your circuit. Let's see how many times can you turn it on and off in 30 seconds. Have fun, and I'll see you next week with a new lesson.